Right, in the previous chapters, we looked at what a tangent and normal were, right? So a tangent is a line which just crosses the function once, and a normal is a line perpendicular to the tangent. So, and we were asked to try and find those line equations. So we need to find the gradient and then find the y-intercept. So if I was to draw a function like this, a tangent would be, for example, a line which looks something like here, where it crosses just once. And a normal would be a line which goes maybe like this because it's at 90 degrees to the tangent, okay? And they were both in the form y is mx plus c because they are just straight line equations. But before when we're trying to find a gradient, we do two coordinates and then find change in y over change in x. But in this case, what we're going to do now is actually we're going to differentiate a function term. So if this is y is f of x, we're going to differentiate that, or f prime of x, you can write it like this. And then we're going to plug in an x value into that, specifically this x value where it crosses where the tangent is going to cross. And that will give us the gradient at that point immediately. So we don't really need two coordinates anymore. We can just differentiate the function and plug in an x value, and this will give us the gradient of the tangent. Okay, and then from there we can find the line equation. Right, for the normal gradient, we know that normal and tangent are perpendicular to each other, right? So for the normal gradient, then we just have to do minus 1 over the tangent's gradient. So in this case, minus 1 over f prime of x. And therefore you get the gradient of the normal, and then we can find the straight line equation. So using that knowledge, let's try and solve this question here. So we have the coordinates of a point with a tangent to the curve y is x squared plus 1 at the point 2, 5 meets the normal to the same curve at point 1 over 2. So we need to find the coordinates at which they intersect. So let's just draw it just to visualize it a bit more. So we can draw like this. The function is y is x squared plus 1, so it's an x squared graph. So it looks something like this. Okay, and we're trying to find the tangent to the curve at 2, 5. So let's say this is 2. So the tangent will be this line here. And then it meets the normal to the curve at the same point at 1, 2. So this is 1 here. So 1, this will be, the normal line will be like here. So we're trying to find that's a tangent line, so we're trying to find the normal equation, this one here, okay? So let's find the tangent one first. So we know y is x squared plus 1. So we have to differentiate this dy by dx, which is just 2x like this. Now we plug in the coordinate of that tangent, right? So the tangent's coordinate will be x is 2. So that's x is 2. So the gradient for the tangent will be 2 times 2, which is equal to 4. So it'll be y is 4x plus c. Now we need to find out plus c, right? So we need our x and y positions, but at that point is 2, 5, which I can plug in. So we get 5 is equal to 4 times 2 plus c, so c is going to be equal to negative 3. So y is going to be 4x minus 3. So this is the tangent equation. We now have to find the normal one at 1, 2. So the same thing, we already differentiated it here, right? So we just have to plug in 1 into that equation. So dy by dx is equal to 2. And remember, this is the gradient of tangent, right, at that point. So if we want the normal one, then what we have to do is just do minus 1 over 2. So y is minus 1 over 2x plus c. Plugging in these two values to find the c. So we have 2 is equal to minus 1 over 2 plus c. C is 5 over 2. So y is equal to a half x plus 5 over 2. So this is the normal equation here, and this is the tangent equation here. And they're asking us to find the position at which they intersect, so you just have to equate them together. So I can say that 4x minus 3 is equal to minus a half x plus 5 over 2, like this. What do we have here? So we have 9 over 2, x is equal to 11 over 2, so x is 11 over 9. I can plug 11 over 9 into either equation, and if you plug that in, y, I think you get 17 over 9, like this. So the intersection point is 11 over 9, 17 over 9. So this last part is not that important. The important part is finding this normal equation here and finding the tangent equation here by using the derivative of the function. Okay, let's show one more. So we have the point P with x coordinate a half, and it lies on the curve with the equation y is 2x squared. So let's just draw that again, just to visualize it a bit more. So x is an x squared graph, so like this, like so. So y is 2x squared. The normal to the curve at P, so P is at comma 1 over 2, right? So this is P here. The normal to the curve at P intersects the curve at the points P and Q. So if I draw the tangent line like this, the normal would be a line which grows like here, right? So if I was to extend this graph here, so it's going to intersect the curve at P and at Q, so Q is going to be roughly here. And they're asking us to find the coordinate of Q. So in order to do this, we need to actually find the normal equation first. And so we differentiate just to get the gradient. So dy by dx is 4x, and I plug in the x coordinate, which is x is a half. So the gradient is going to be 2. Remember, this is the gradient of the tangent, right? And we're looking for the normal equation, the normal gradient. So m is going to be minus 1 over that, so minus 1 over 2. So y is minus 1 over 2x plus c. Finding the c, well, we have the x coordinate, but we need the y coordinate, right? So what I can do is just plug this into this curve equation, can't I? So if x is a half, I can say y is 2 times a half squared. So this is 1 over 4, so this is also a half as well, which I can plug into here. So 1 over 2 is equal to minus 1 over 2 times 1 over 2 plus c. So c is going to be 3 over 4 like this. So the normal equation is going to be y is equal to negative a half x plus 3 over 4. Okay. Now q, as we said earlier, is the point at which a normal equation intersects with the original equation, right? So we can just say the equation here is equal to the normal equation we found earlier. So I can say that 2x squared is equal to minus 1 over 2x plus 3 over 4, and now I just solve for x. It's like a quadratic equation, so let's just multiply everything by 4. 8x squared minus 2x is equal to minus 2x plus 3. 8x squared plus 2x minus 3 is 0, which I can try and factorize. So what do we have here? We have 2x, we have 4x, and we can have minus 1 plus 3, meaning x is going to give you 1 over 2 and negative 3 over 4. As you can see, we get two values of x, right? Meaning there's 2 points of intersection, which is correct because we have p and q. And we already know that x coordinate of p was a half, so this is a coordinate for p, so meaning that this must be the x coordinate of q. So if x is negative 3 over 4, to find y, I just plug it into either equation, right? So y is going to be 2 times minus 3 over 4 squared. So this will give you 9 over 8. So the coordinate of q will be negative 3 over 4, comma 9 over 8. So that's how we use the normal, or how we find the normal equation to then find the intersection point between the normal equation and the curve. So as long as you remember the derivative will give you the gradient of the tangent, and then how to find the normal gradient from there, then you can find all these different types of straight line graphs.